Good morning, everybody. So just before we start, I wanted to make a disclaimer. This presentation will contain demo and relies on it. And I learned from this week that demo gods are probably live in North America because somehow they were disturbed by the solar eclipse during the week, and everything failed throughout the week. So if something fails today, please bear with us. Apologies in advance. We'll try to do our best. And actually, it's not just my feeling, but other presenters also complained about some problems with the demos this week. Okay, let's start. Okay. Well, a few words about myself. I'm based in Singapore. I'm heading a small team of researchers in Asia Pacific. I like reverse engineering, malware analysis, cyber investigation, digital forensics, and that's what the presentation is about. I'm here with my colleague, Wayne. He joined the company just last year. He's growing up and helping me with the demo today. We'll show something cool in the end of the presentation. He is actually one of the interns who spent 1 year in Russia, working for Kaspersky as an intern in Moscow. And that's quite something, I think, to survive 1 year. If you're from Singapore, it's tough. So he had his training, tough training, and looking forward for his future research. Now, the talk is about finding a needle in a remote haystack. By this, we mean doing cyber investigations in a remote location. And the reality actually is that technical skills of many investigators, I know a lot of folks from law enforcement, they actually need some improvement in terms of technical skills, for sure. We are trying to help them with this, and it's one of the reasons why I joined Interpol here in Singapore, because a lot of people, they just don't have enough of experience of the malware forensics, malware analysis. And sometimes it's maybe a developing country which cannot afford an expensive software and hardware that is used for forensics or even malware analysis. And also low availability of the experts in this field makes it hard, so that they cannot really rely on private sector or some local experts from their country, because there are just very few of them. And sometimes it's just budget issues or visas or time constraints that prevent them from traveling overseas and doing investigation in a remote place. Cross-border investigations is something really, really hard. That's what I learned while dealing with law enforcement folks. Now, we wanted to help them with this, to overcome this. And we look at the existing solutions. Basically, as a result, we have a low speed of cyber investigations and high level of cybercrime, apparently. So the existing approaches include time warping. That helps, like if you have some extra hours in your clock, that definitely solves the problem of lack of time. So different people apply different approaches to solve it. Some did very good, I think. Some are not so good. Still, this is the prior research to the problem. For me, it was like mind-bending a bit, so I'm not good in time warping. So I tried to use something that is applicable and useful to me, that I can implement. The alternative approach was space traveling. So if you do space traveling, it definitely solve the problem of visas and the lack of time and everything. You can quickly jump to the location and do your investigation in place. But again, this is quite dangerous. So actually, I don't recommend to try it at home. So it may actually end up not so well to you. So I decided not to go into this area and instead use some poor man's solution, which is based on accumulation of technical skills in one place, reduce the travel time or kill it, and do instant investigation support through one simple thing, which is remote digital forensics, as you guessed. And today we're going to show the tool that help us do this. There are some existing commercial forensic solutions that provide a remote capability. So the pros for this is that they are ready-to-use solution, apparently. Like one click, everything is done. I don't know whether it is pro or con, because it just makes the life of the investigators easy to the extent that they actually don't understand what they are doing. They just know how to click the button, so which is as a negative effect. So then it's supported by a vendor, which is kind of good. It can be like you can have the problem fixed. It's simplified usage, already mentioned. But cons include first product price, the renewal costs, then the training costs. All of this is super expensive. Then you depend on the vendor. If you need some features, you have to ask the vendor. It comes with the product limitations, apparently, and sometimes even introduce evidence tampering by inserting some agent on the running system, for instance, or even doing something that is unclear to the expert, like, for instance, fixing errors on the corrupted file systems. Some of the forensic solutions were seen doing that. And sometimes the remote forensic tools are hardware-based, so you have to physically transfer the expensive device to use it on the remote location. So we thought, like, why not to use a solution which is free with free upgrades, tested by millions of people for years, runs on any CPU architecture merely. It's limited only with your hardware constraints, and it's tamper-free, transparent and verifiable because it's open source, and enable local and remote usage both, and it's customizable because it's a do-it-yourself tool. So where to find such thing? We found it like simple answer. I'm sure most of you will agree with me here. It's actually already implemented in Linux world. There is a plenty of free and open source forensic tools, and remote capabilities are awesome. It can work over low bandwidth connection, and so on. So we decided to build our own live CD, and more to that, we decided to make a constructor that builds live CDs, forensic live CDs. And we decided to make it open source, so that everybody can customize and use it. So this is how it looked in our case. So we called BitScout. That's the bootable minimalistic live CD. It doesn't have GUI, it doesn't have X server. So it's designed to be like Spartan interface, so that the user that sees or boots this live CD from a CD that we deliver maybe as an ISO file, just need to do initial settings, like configure the network. The rest is done by us. And maybe one more thing, to authorize the start or access to the hard drive to begin the investigation. So it's like super minimalistic. There is no GUI, as I told you, but there is a menu for the normal user to use arrow keys and enter button. Everybody knows how to use that. So it saves us a lot of RAM because we run in RAM as a live CD. And also it reduces the size of the whole ISO file of the disk image. If you want to transfer it over the network to the owner of the infected machine to burn it on the CD, it has to be like as small as possible. So this is one of the constraints. That's why we decided to stick to this simple text UI interface. Now, how the project was started, it actually started like several years ago when we had somebody in a remote location, and we really wanted to find the infection vector, how the machine was breached. It was one of the allegedly nation-state-sponsored targeted attacks, and the machine popped up in like very, very distant country to us. And we had no plans, no money, no time, no visa to travel there. So we built something from scratch, like quickly. There was live CD based on Ubuntu live CD. We just customized it. We added OpenVPN and SSH and made it automatically back connect when it boots, so that it connected to a trusted server, and then the expert could SSH in and have access to the hard drive. So that was well. It worked very well. We found what we wanted to, so it was excellent. So for some years, we kept it in our pocket, and we decided to release it now with additional idea, which make it more attractive and more transparent to everybody. Because when I give some binary file full of executable code to an owner of the machine, the owner somehow has to put a lot of trust into me to let me access the hard drive. So we decided to isolate the expert. Instead of accessing the physical system and access and work with physical HDD, we actually create a projection like we create a mapping, which is a virtual HDD. It's actually the block device that you can access from the container. So you work within the container. Container, it's like a virtual machine, right? But not really virtual machine. Virtual environment where you are root. You can modify any files. You can install additional packages, any software that you want. You're root, basically. But within this chroot environment, so to say, with additional layer of Linux kernel isolation. So you are God within the container. Outside of the container, you are a normal user. So you cannot actually insert kernel modules. You cannot escape the container. So that's the idea, that's the design. But still, you are running as an unprivileged user outside of it. So the architecture includes, like, on the physical host, we have a network card that's essential. It can be Wi-Fi if it's a laptop that you need to analyze. There is an HDD, which is essential part. And then we established the VPN connection to the server, which means another interface, a virtual one, which we connect to the virtual interface within the container, okay? And we map the physical hard drive to the Evidence0 block device, which looks like a hard drive to us, and we can work with it. And all the write operations will not be permitted. So they will be denied when you try to access it in with any possible that we tried operations to write or modify or change rights or anything, even if you are root. Now, to make sure that, sometimes we actually bumped into limitations of the unprivileged user. For instance, when you want to mount a file system, let's say X4, so there are two ways. One, you can use user mode file system, which is Fuse module, which is not working very well. It's still like in development, I think. And the other file systems, they just don't have the Fuse driver, which means you have to use native kernel module to mount the file system to be able to see the files and work with them. And that requires privileged execution. So we introduced certain kind of shim to do the privileged execution on the host, which we try to make as secure as possible, but you are very welcome to break it, hack it, and please report it. But in case there is like a really evil expert that is not an expert, but a scammer, we at least record the session, like all the SSH, all the shell sessions are recorded in like text mode. So with the timing information, so that you can replay what has been done to the system, which is also useful in court. For instance, you can see how the evidence was discovered on the hard drive, because you can replay, you can pause, you can see like what the expert typed, what tools he ran, and what he saw as a response to this. So it's like almost video, but in a text mode. Now, you can build your own operating system. I mean, your own CD-ROM. You can stuff it with your tools. You can put all the forensic tools on it, and it's still less than 700 megabytes, which means it can easily be burned on ISO. There is actually a nice package on Ubuntu called Forensics All, I guess, and it includes like dozens of different tools. In most of the cases, we need just maybe 5, but there are plenty of those in case you need it for any possible field operation. You stuffed it on this hard drive, which will be still less than the size of the CD, because we don't use the X server. So we normally use the medium, the proper elephant, because we don't want to make it giant and big to transfer the network. So what else you can do? Few features. This image acquisition with non-skilled staff. So all we need is to let the user boot that CD that he burns from another station, perhaps, on the infected machine. You connect to it, and then you ask, like, please plug the USB external hard drive. And then you can do the disk image for the user. If it's a law enforcement officer, you do the proper forensic disk image. So you make the image, you hash the file, you put everything there, meta information, and so on. You can do training, because you can actually share terminal sessions with other users so that they can learn from you. It's also recording all the actions so that they can use it to replay and show the students like what the experts are doing when they analyze the hard drive. You can, of course, transfer the disk image if you want to, because you have network connection, you have full access to the disk, read-only. You can copy if the network allows. But the design actually allows you to analyze everything on place. You don't need to transfer the image over the network most of the times. You can scan with Yara signatures the affected system, which is powered off, which is important because certain rootkits actually hide presence of the files, and you cannot access and detect them with Yara running natively on the infected machine. That's why powered off system is a must here. Of course, work with registry, get the autorans list, the remote file carving, and even remediate the system. So the owner can actually explicitly allow you to have access, which is read-write, to the hard drive. Because sometimes it's important. You know, in cases, from my experience, users sometimes ask like, okay, I'll give you access to my machine, but when you're done, can you please kill the virus? And I'm like, okay, sure. So you can just disable the malware at least. And of course, you have presence to the remote network. It's up to the settings in your build to allow access to the network where you are or not. It's a matter of firewall on the host outside of container, but theoretically it can be used like for remote incident response and even security assessment if you like, because it's actually remote shell and you have all the Linux tools like scanners and stuff. And we did that, in fact, in some of the cases. We found there was a passive backdoor installed on the infected system. So we reverse engineered the backdoor. We realized like what port it is running on, what protocol it speaks. We made the NEC scripts for Nmap and then scanned the whole range of the hosts in the same subnet just to make sure that there are no other listening backdoor in the same subnet of the customer. And one more thing. We decided to at some point enable write access. And it's not just enabling write access to the evidence drive, but virtualized write access in this way. So we only have a remote system. We thought if we enable write access, which will be virtualized, where we can redirect write operations to some local database or local file with changes added to the evidence hard drive, then we can use it to boot the whole system within the virtual machine. Because Windows, for instance, it cannot be booted if it doesn't have write access to the hard disk. It will just crash immediately. So to boot Windows in the VM from the remote hard drive, you need to have write access. So we kind of divert and redirect these operations for changes to the disk to the local file, which can be discarded. So the evidence hard drive on the remote system is untouched. And we can access this over the network block device so that we can run VM not remotely on the same machine on the live CD, but locally in our lab. Why it can be useful and why we actually going for this is because, we thought like this is really cool tool for offline forensics, but what about the memory dump? The user sometimes not capable of just even running the tool and doing proper memory dump. So having a live system running even within the virtualized environment and analyzing that memory dump may be useful just to speed up the process of the analysis so that you can see all the executable modules that start on boot, and then you can see them active. You can see the traffic. You can work and interact with the system. You can add tools to it. You can install Yara, you can install EV if you like, and then scan the whole disk if you want within environment that will not add any changes to the original drive. So we thought this idea is pretty cool, and we wanted to show you how it works in a live demo, like at least starting the machine over the network. So right now we have 2 laptops here, and this Ethernet cable. They are connected now over LAN, kindly provided by friends. Can we please switch the output to the second machine so that we show you what is there? Okay, we're done. Can you continue? So we have this Windows machine, which is allegedly infected. That's the owner logging in. And just for the sake of verification, we're going to leave a message on this machine on the desktop, a message that I will open from remotely through this BitScout remote forensic. So I'd like to ask Wayne to open Notepad and type a message. Can you please delete this one? Can we please add some message? Anybody can any message from the audience that we shall put just for the sake of objectivity? Where is my beer? Okay, there was another one. Let's put 2 so that it's not a setup. What's that? I love Singapore. Fantastic. Where is my beer? Everybody has his problems. Okay, so we now this system is allegedly infected. So the owner shuts it down and has to reboot it from the live CD, which we already put in the virtual CD-ROM here. So this is the grab menu. So it shows you some internal information. In case it crashes or stops or it's incompatibility with the hardware, at least the user can take a photo on the phone and then send it to you so that you can understand like what needs to be tuned. That's why we show all this output. And it tries to get an IP from the DHCP server. If it's not available, it's possible to set it manually through the same menu. So this is how the menu looks like. So basically, we have the network settings first, where in our case, we'll set a static IP because this is a peer-to-peer connection. I don't run the HTTP server here. In real life, the user doesn't need to do that. It's possible to enter proxy, SOCKS and HTTP. If in case it's corporate environment, you connect through proxy, so it will VPN over proxy. So next thing, the owner has to authorize access to the disk. So we go to the disk menu, and we have to map the device to the container. So this is the list of physical devices. So first we mount it to evidence. Okay. So there are a list of predefined evidence block devices that you can use for mounting. So we mount two things. One is a full drive, so that we will boot the system, and second is just the partition, the Windows partition. So I just wanted to show you the contents of that file on the desktop. Okay, can you show the status if the VPN is up? So the VPN is up. This is a status window. There is a tab 0 interface, which shows that the VPN is connected. There's a log of the VPN, OpenVPN, which shows initialization sequence completed. So we are ready to connect. And just before we switch, let me show you what happens after I connect over SSH. So I am connected to the VPN server. Okay, sec. Okay, I have just connected to the machine. Let's see if it works. On the bottom here, it's hard to see from the back row, I know, but this is like user 298. This is the PID and the username of a remotely logged in user so that you can monitor live what I am doing. So the owner can see what's going on. So if I type hello, it will be displayed on his screen, okay? And the more users you have, the more tabs is added, and everything, of course, is recorded and saved to a file so that you can see it later and analyze what happened. So I'm just going to become root here. So you see another root session opened because I ran sudo. So I am root within the container. Okay. Now let's switch the displays again. Can we switch the output? Okay, now I'm going to show the terminal here. Let's see if it's workable. Okay, so this is my SSH session on the BitScout. So first thing, let's mount that drive which is accessible through this device, OS host evidence, evidence 1. So we can see the size of the block device in bytes. It has to be, I think, partition C, right? Drive C. So we're going to mount this device and find the text file, the message. So user, desktop. And the daily log.txt. Okay, can you see it? I love Singapore. Hello, where's my beer? Okay, so we connected to the right system. It's not fake. Now, this is fine, but let's see how the system can be booted remotely. What I'll do now is I'm going to start here first. The first thing, I need to create the hard drive. Let me show you this tiny script that will actually connect to the NBD network block device that is accessible on the BitScout machine. And to do that, I gotta start the NBD service and map it to the right block device so that I can access it over the network. me sync. So we get to edit this NBD server config. I deliberately didn't pre-configure the image just to make sure to show you how that this is done pretty easily. So I just add the port number to listen on, and then the device to export, which is this. The evidence 0 contains whole disk. Okay. Now we save it, and we need to restart the NBD server service. Okay, theoretically it shall be now accessible, and then I will create the remote, a mapping to remote drive locally. So basically it will create this file qcode2, which will contain the changes that are write to the remote device. So all write operations will be redirected here. Okay, now it's created. This is the file, the fresh one. It's 100K only. And now let me start the virtual machine using this qcode file as a hard drive of the virtual machine. Okay, so you see it's 100 kilobytes size. And now, where's my virtual machine? Okay, it's here. Sorry, it is booting. So now I'm booting Windows over the network using this network block device from his machine. And it's pretty fast. I don't know your password. Can you type it? Now we have the same daily log. You see, hello, I love Singapore. No beer for you. Okay, so now the machine is running locally, okay, and the distance between us can be like in thousands of kilometers, right? And we can interact with it, we can add tools to it, we can have a network share map to it, and anything. We can map USB drive to that remote machine, to the local, sorry. I'm not confused where is local, where is remote. But the most important thing is we can dump memory and analyze it with your tools of preference. So we can dump memory externally on the hypervisor, right? So it's not actually introducing anything to the machine itself. It's not alerting the malware that I'm going to dump the memory. So we will not shut down. Let me say I can do. So this is a simple command that just instructs the virtual machine manager to dump the memory into memdump guest.dmp. Okay. Done. So let's see, we have this file, 500 megs. I actually started it with reduced RAM. I can reduce it to as little as I want. If he runs 4 gigs, I may not need this 4 gigs of RAM. I can adjust it to just 500 megs, whatever I want. Now we can run volatility on this and see, let's say, network connections, okay? So you can check the network connections, and you can, I don't know if you can see anything spooky here. It's misaligned. Sorry, because of the size of the resolution, but let's see if we can notice anything. All right, super bad for the demo. Okay, maybe somebody sees this 6666, which is just one spooky port open there by ctfmon.exe. What we can do, of course, with the volatility, I'm sure most of you know, but we can do like PS list to see when this process has started, if there are 2 of these, because there are apparently 2 ctfmon. Or is it just one? Okay, it's just one. But then we can dump the process using the PID. It's 1584. Can do proc dump. Basically, the plugin dumps all the processes, and we just need to find the right one by PID and the name. So that's cdfmon. this file. So if we go to memdem folder, 1584. So yeah, this is the MZ header, and this is the P file that we dumped externally from the hypervisor. And this is actually the malware loader, which loads another DLL and opens and that opens specific port for listening. So then you can see which DLLs are loaded into that process, dump it, and analyze it offline. I'm actually ran out of time, so that's it for the demo. At least it booted. Demo gods are with us. Maybe the solar eclipse has really passed. All right, where is our slides? One important slide here. Thank you. So I don't think we have time for questions. I don't want to delay other speakers, but if you do have questions or want to download the tool, it's available on GitHub here. Currently, it's under my account. We're going to move it to a company's account and introduce new features. So feel free to play with it. Let me know what you think, if it helped you. If it doesn't help you, if you think it's bullshit, let me know. But if it helps you, please tell me your story. I would love to hear what you can do with this. Because one guy has already did something interesting. And this is actually the next talk on this track. So please stay with us. There will be an independent talk that is going to show BitScout at work with some, I would say, bizarre demos.